talk about voltage drop. Voltage drop in a 100-foot extension cord, a 16-3 extension cord. In order to find voltage drop, we just use Ohm's law. Voltage is equal to the current times the resistance. The formula for voltage drop is 2 times the resistance times the length times the current divided by the circular mil of the wire. We'll put some numbers to it. Now, this 2 is just because we have a single phase. We have 2 current carrying conductors, the hot and neutral. They both carry current. So in effect, we're measuring the resistance of a wire that's 200 foot long. We could eliminate the 2 and just call this 200 feet over here. But we leave the 2 in there. And when we use a 3-phase circuit, we have 3 current carrying conductors, but they're each 120 degrees out of phase. And so we take the square root of 3, which happens to be 1.732, but we won't get into 3-phase. We're just using a single phase cord for now. So we take it 2 times 10.371. This 10.371, that's the resistance of a piece of wire that's 1 circular mil, 0.001 inch in diameter, by 1 foot. So we take the 2 times the resistance times 100 feet times the amperage, 10 amps. We're going to use 10 amps. That's the maximum we can put on this cord. If we did that, we would find the voltage drop for a piece of wire that was 200 foot long by 1 circular mil. But we have 16.3, which happens to be 2,583 circular mils. So we divide by that, and we get 8.04 volt. That's going to be our voltage drop. We're going to lose that much voltage in the cable. Now, if we divide that by 120 to get our percentage, it's going to be 6.7% volts drop. Now, the National Electric Code, they recommend that you have no more than 5% voltage drop on a combined feeder and branch circuits, but that's just a recommendation. That's not code. So 6.7 voltage drop is fine. How many watts are we going to lose doing this? Well, if we have 8 volts and we drop on the cord and there's 10 amps running through there, we're going to lose 80 watts. We're going to dissipate 80 watts into that 100-foot cord. We're going to test our cable, see how much resistance is in our cable. So we're going to take the 10.371 times 100 feet, and we're going to divide that by the circular mil of the number 16 wire, and it should come up to 0.4 ohms per 100 feet. We'll see if we've got 0.4 ohms in our cable. According to this meter, I have 0.4. Well, it's fluctuating around 0.5 ohms. We'll take it out and test it with a underload. Yeah, I have a 1,000-watt heating element plugged in out here in the shop, and I have 118 volts. And I'm drawing 7.91 amps. Now I'm running it through extension cord, and I've got 111 volts. And I've got 7.45 amps. We had a 7 volt drop, but we didn't start off with 10 amps, only 7.91 amps. And if you plug that into the formula, it should come up to 6.3. We're off by 0.7 volts, but for the setup we had, we're probably in the ballpark. I'll leave you with an overloaded cable.